Inside every car on the road, there's this constant, invisible decision being made. A decision that pits millions of dollars in savings against mission-critical reliability. And it all boils down to a super simple question. When do you use one wire, and when must you use two?
It seems like a no-brainer, right? In automotive engineering, every single component, every single gram of weight, every penny of cost is just relentlessly scrutinized. So if you can get a job done with one wire instead of two, saving all that money and complexity, why on earth would you ever choose the more expensive option? That is the core puzzle we're going to untangle today.
So your car, it's this incredibly complex network. You've got dozens of little computers, these electronic control units, and they're all constantly talking to each other. They control literally everything, from your engine timing all the way to your power windows. And every single decision about how they communicate is this critical trade-off, a constant fight between keeping costs way down and making sure everything works perfectly every single time.
Okay, so to really understand this wiring battle, first, we have to meet the main villain of our story, electrical noise. A running car is, and I'm not exaggerating, one of the most electrically hostile environments you could possibly imagine. You've got spark plugs firing, motors spinning, the alternator whining. All of this just creates a massive storm of electrical interference.
Now, for any electrical signal to make any sense at all, you need a stable point of reference. Think about it like measuring your height. You need a flat, unmoving floor to get an accurate number, right? Well, in electronics, that floor is called the reference potential, or ground. It's the 0-volt point that all the other voltages get measured against.
To save a ton of wire, car makers do something pretty clever. They use the entire metal frame of the car, the chassis, as one giant common ground connection. It's a fantastic cost-saving move. But here's the problem. Because of all that electrical interference from everything else happening in the car, the voltage of that chassis ground isn't perfectly stable. It actually fluctuates. It's noisy.
And this right here is the perfect analogy for the problem. Trying to measure a signal against the car's noisy chassis ground is just like standing in a small boat on a really choppy sea, trying to measure the height of a flag on a pier. Your reference point, the sea level, is constantly moving up and down. So how can you possibly get a reliable measurement?
So how do engineers deal with this whole floating reference point problem? Well, the first and most obvious solution also happens to be the cheapest one, the single wire system. In this setup, you have one wire and it carries the changing voltage of the signal itself. The receiver then measures that voltage relative to our choppy sea, that unstable chassis ground. You can probably see the potential problem right away. If the ground level shifts just as you're taking a measurement, well, your measurement could be completely wrong.
So this is the trade-off. The huge, massive advantage is cost. It's the cheapest possible way to connect two components, period. But the downsides are pretty significant. It's super vulnerable to all that electrical noise, and to deal with that, the signals have to be slower and kind of louder, which really limits the maximum data speed you can get.
But what about the really critical systems? Like your brakes or your engine control, where a misread signal is just not an option. For that, engineers turn to a much more elegant and robust solution.
Now this is the really clever part. A two-wire system, what we call a differential pair, it doesn't care about the choppy sea at all. Instead of measuring one wire against that unstable ground, it measures the difference in voltage between the two wires themselves. It completely ignores the chassis ground.
Let's jump back to our analogy. This is like completely ignoring your bobbing boat and instead measuring the height of the flag using two marks you've made right on the flagpole. See, even if the entire pier sways in the wind, the distance between your two marks on that pole stays exactly the same. You get a perfect measurement every single time. That right there is the magic of differential signaling.
The benefits here are huge. You get fantastic immunity to noise, because any external interference is going to hit both wires at basically the same time, raising or lowering their voltage together. And since the receiver only cares about the difference between them, that noise gets canceled out. It's brilliant. And this incredible reliability is what allows for much, much higher data speeds. The only real downside? Yeah, it costs more. You need two wires. This table really just lays out the choice for engineers perfectly. When you're talking noise immunity, the two-wire system is way, way better. And because of that, it allows for much higher maximum speeds. But when it comes to cold, hard cash, the single-wire system is the clear winner. So if you need speed and rock-solid reliability, you pay for two wires. If your system is slow, non-critical, and you need to save every last penny, you use one. It's a classic engineering trade-off.
Okay, so this isn't just theory. This exact trade-off is made thousands of times in the design of every single car out there. Let's take a look at how this plays out with some real automotive systems.
Here it is in practice with two super common automotive networks. The LIN bus, that's Local Interconnect Network, is a single-wire system. It's slow, maxing out around 20 kilobits per second, but hey, it's cheap. So it's perfect for things like your window controls or your seat motors. But for the critical high-speed jobs like engine management or your anti-lock brakes, engineers use the CAN bus, the Controller Area Network. It's a robust, two-wire system that's over 25 times faster.
So the most important point is this. There is no single best answer. An engineer's job is to analyze all the requirements, speed, reliability, cost, and then choose the most appropriate tool for that specific job. I mean, using a two-wire system for a dome light is just wasteful, but using a single-wire system for airbag deployment, that would be dangerously irresponsible. And this is more critical today than ever, with systems like advanced driver assistance and drive-by-wire that rely on this robust communication to literally keep us safe.
And that's a decision that's made for every single function in your vehicle. So the next time you push a button, whether it's to lower a window or to turn on cruise control, maybe you'll think about that invisible battle of one wire versus two and all the clever engineering that makes it all just work. Thanks for watching.